The tempering of the pies for this practice is done in the lab faucets at 900 degrees Celsius in water. This will allow us to compare the tempered hardness result with not tempered metals ones. In order to perform hardness tests, the metals must be present encapsulated. To do this, a metal simply must be present into phenolic powder with a stuffer.
The sample is placed, keeping it centered after the mold release has been applied. Then, the resistance is applied and the cover is closed. Pressure is bumped until the red dot is on. This must be maintained during 10 minutes. A special mirror finish is required for the Vickers test, which is achieved by polishing the surface previous to the test. For the Brinell test, an indentation of 2000 kilograms is applied on the metals. The first step is to calibrate the load. Then, the 10 mm spherical indenter is actioned in the central part of the metal's surface during 15 seconds. The diameter of the indentation is then measured with the microscope, and the hardness-Brinell to millimeter relation is obtained. The process has to be repeated 3 times in order to obtain an average value. For the given 1045 and 1018 samples, the results of the test are 269 Hb and 276 Hb respectively. These results vary slightly with the theoretical, which are 278 Hb and 126 Hb.
The Rockwell test determines the hardness by measuring the depth of the penetration of an indenter under a larger load compared to the penetration made by the preload. For this test, the sample is kept in the center and pressure is applied by actioning manually until the indicator needle turns 2 times and is kept in 0. The lever is pushed forward and then taken back once the needle stopped moving. The needle indicates the resulting hardness in the HRC scale. For the performed tests, the results were 18 HRC for the 1018 steel and 20 HRC for the 1045 steel. The theoretical results for both types of steel were 53 HRC and 55 HRC accordingly. It is important to mention that there are other Rockwell scales that change according to the indenter shape and material that it's made of.
The automatic Vickers test involves the use of a specialized software to perform the indentations in the materials. The load is applied during 15 seconds in which no external movement should be performed due to the high sensitivity of the devices. The encapsulated samples are centered in the Vickers machine support and the function for the load application is activated in the software. The result are diamond-shaped indentations, which are measured by the software itself. The results for the 1018 and the 1014 steel are 289 Hb and 180 Hb respectively. The manual Vickers test involves the use of the microscope for the indentations measurement and the mechanical activation of the machine gun. The 300 grams applied load is applied during 15 seconds in the same way in which the automatic setting was applied, and the extreme of the generated diamond shapes are measured through the microscope. For the practice, it was expected for the samples that were heat-treated through tempering to have a higher value of hardness over the samples that were not heat-treated. This was true for the 1045 steel, given that its hardness increased 11.5 points of hardness on the HV scale. For the 1018 steel, the hardness decreased in the heat-treated sample by 121 points of hardness on the HV scale. This result that contradicted our initial hypothesis was researched, and because of the low carbon concentration on the composition of the 1018 steel, this type of steel softens when it is subjected to tempering. The 1018 steel does not have a conventional response to tempering. If an increase in hardness is needed, processes such as carburizing and quenching can be used.